going to have much more jerky motion where we're allowed to suddenly just shoot off to the left, suddenly shoot off to the right while keeping our forward motion. We can throw rockets on to randomly break without having to worry about crashing down to a planet like you have to worry about within an atmosphere.
But without any atmosphere to slow spacecraft down, could space dogfights reach such high speeds that the human pilots would begin to fall apart? That's what Nicholas B. from Ziegler, Illinois wanted to ask the universe. So he texted, "At what speed do human atoms start to break down?"
Nicholas, your question actually is about a common but very understandable misconception. It turns out that atoms are stable at any speed because in their own frame of reference, they're at rest. However, humans die if they're subject to sustained accelerations greater than about 10 g. So I would say that's the practical limit for accelerations during interstellar travel, 10 g.
But how can there be g-forces in the emptiness of space where there's barely any gravity at all? It's all because of Albert Einstein's equivalence principle, a key part of his theory of general relativity. It states that gravity and acceleration are equivalent, like an elevator accelerating up, making a passenger feel like there's additional gravity pushing them into the floor.
So if you moved around too quickly in space and you jerked real quick, your brain would move around inside your skull so quickly that you could kill yourself. And so you might want the guidance system of your spacecraft to keep you from making those types of maneuvers.
Or future strategists may decide to keep pilots out of the fight entirely. So then what would a pilotless battle in space look like? Because of the complexities and dangers of dogfighting in space, pilots may be left out of future space battles altogether. Imagine our pirate ship 200 years in the future trying to take over the supply ship while all of the people remained on the two main spacecraft.
Assuming you had a large manned or piloted spacecraft that was engaged in combat operations with another vehicle the same size, you wouldn't launch fighters at it. You would throw some tiny space mine maneuverable vehicle the size of a suitcase that would be stealthy, would float up to the enemy spacecraft, attach itself, and blow up. That would be the way you do it.
But even though piloted space fighters may not be a dominant weapon in the future, lasers are still likely to play a role if war comes to space, although they will have some challenges to overcome. 30 years from now, a ground station on Earth is trying to destroy an enemy satellite with a laser. But before it reaches its target, the beam will have to deal with Earth's atmosphere.
If you've ever stuck a straw into a glass of water and looked at it from the side, you might have noticed that the straw appears to bend as it goes through the surface. This is because light gets bent as it goes through one material and into another. Well, lasers passing through our atmosphere have to deal with the same sort of problem, refraction. So when we're trying to point lasers from the surface of the Earth out into space, we have to take into consideration how much the atmosphere bends light.
A laser weapon already in space will be much more effective at taking out satellites or spacecraft.
Up in space, there would be no atmosphere, and so there'd be no attenuation of the laser light as there is when it's going through the atmosphere.
But until scientists come up with a strong, lightweight energy source for use in space, lasers won't be powerful enough to blast anything. And the same kind of energy limitations will likely keep laser weapons out of the hands of space soldiers.
Until we create a fusion reactor in a cell phone sized battery, we're not going to be carrying those things around anytime soon that do real damage. Like Captain Kirk's handheld phaser that he shoots and destroys and completely disintegrates somebody. That takes a lot of power. I'd like to know what power source those things have in them.
So if lasers don't turn out to be the dominant space weapon of the future, then what might a battle on the surface of the moon look like 100 years from now?
As colonies often do, they get into a dispute and have some kind of war. You would think it would be fairly short. The environment is so hostile to begin with, you're lucky to be alive.
The attacking force approaching the rival colony will probably be fairly small due to the harsh conditions and the huge cost of bringing people and equipment into space. And for the same cost-saving reason, the colony will also be made from lightweight, thin materials.
It costs way too much to send stainless steel or whatever would be heavy, armored plating. That's not what the first colonies are going to be, and they're going to be very fragile.
So even a simple attack could be very effective.
I think you would just find somebody trucking a bomb over to the wrong place and sneaking it in and setting it off. Or launching a small missile at somebody. It would be incredibly hard to stop. It would be incredibly easy to get everybody killed.
But if the strike force isn't able to take out the colony right away, they might face a counterattack out on the surface of the moon. Here in the vacuum of space, even the smallest wound can be a death sentence.
If a hole were punched in the spacesuit, it would leak. And by the way, what punched the hole in the spacesuit probably kept on punching through to the person inside it, right? So how do you help that person? How do you perform first aid on them?
But the space wars of the distant future may move beyond the technology of man and machine altogether. After all, the destructive power of natural phenomena in the universe goes far beyond any weapon people have ever made. Looking hundreds of years into the future, a belligerent alien civilization is using Mars as a staging area for their coming invasion of Earth.
One might imagine redirecting an asteroid or a rock flying through the solar system so that it hits Mars. We could imagine firing a rocket to an asteroid, deflecting it ever so slightly in its trajectory so that after a number of orbits, it would finally hit Mars.
But is it inevitable that man will turn the final frontier into a battleground? Or could our advances in destructive technology be matched by advances in wisdom and self-preservation?
Human beings always think that one day soon we're going to move beyond the need for conflict. We haven't done it here, and I don't think we're going to move beyond it in space.
Most countries of the world have already signed what's commonly known as the 1967 Outer Space Treaty, preserving space, the moon, and other planets for peaceful purposes. But as space travel in the future becomes more routine, and if valuable untapped resources are discovered beyond Earth, will a treaty be enough? Only time will tell. This arsenal of exotic space weapons is a preview of our future, or a dangerous fantasy world we can avoid.